So, DNA code, and this, what becomes real cool about this, all DNA-based forms of life, from the smallest bacteria, virus, algae, poppy, marijuana, Douglas fir to the largest whale, use chemicals to communicate between cells. Plants, not being able to move, communicate, and defend themselves using chemicals called allelochemicals. So as an example, African bird pepper, also known as cayenne. The reason it's called bird pepper is that what the hot in cayenne and all peppers is a defense against mammals. And it only works against mammals. The plant wants birds to eat the seeds and spread them farther than an animal would. All right? So it devises a defense against the animal, which is the hot. Now, the hot isn't a flavor, it's a chemical burn, literally. There's no taste buds for hot. It's a chemical burn. Right? But us crazy humans, we just cultivate, hotter and hotter, habanero, ghost peppers, et cetera, et cetera. We like that because what it does, that chemical burn, creates an endorphin reaction, one of those chemicals. Right? So we cultivate those. So obviously plants, the marijuana plant, of course, doesn't create THC to get you stoned. It's using it as a fungicide. All right? So all DNA-based forms of life use this. Okay? So animals know this, and we eat certain plants, and humans know this, and we, experiment and use various plants and other things for medicine. So at best, this is good nutrition. At worst, it can become addiction. So DNA, not just a physical molecule, but a set of energy relationships, as all quantum relationships are. The atoms don't actually touch each other, they're bonded energetically. The cell, therefore, does not simply respond to physical and chemical signals, but also energy signals as well. Some are detectable with the current technology, some are not. Now, when I use the word in English technology, you think of machines, right? So this cell phone, like all your cell phones, is a quantum device. Okay? The basic quantum physics technology was discovered 150 years ago. But it took us about a century to come up with the idea of a wireless phone. Okay? Some of you are old enough to remember telephones that had rotary dials, right? Wired phones. Principle is the same. The electricity is not traveling in the wire, it's around the wire. All right? Quantum energy. Quantum physics says there are energy relationships that go beyond the physical. All right? Same with the cell. The cells are triggered not only by physical and chemical signals, but also energy signals, too. So not just electricity. So some mind-body disciplines, yoga, martial arts, train you to utilize perceivable energies which can be experienced physically and mentally, but are not detectable by Western science. Okay? So the science of acupuncture, this is why the course is cross-cultural. Okay? Got to go outside of Western culture to explain some things that are commonplace. Acupuncture runs on energy called chi or ki. Martial arts, chi or ki. Yoga, prana. Its life energy is not detectable by Western technology. Yet, you can teach a 10-year-old white kid to break bricks using Taekwondo. It's not strength training within the framework. You don't learn to break bricks or blocks of wood just by strength, lifting weights. Otherwise, weightlifters would do it, right? It's focusing your mind and energy, right? That's a technology. It's a way of doing something, all right? So, life energies can be experienced physically and mentally, even though they can't be detected with our current machine technology. So what we do know from a Western framework, so these are two neurons, or two individual nerve cells. So you have billions, like 100 billion neurons. Each individual nerve cell is called a neuron. Billions of neurons in your brain, and none of them touch. They don't physically touch. They're surrounded with glial cells, which are kind of like a smart glue that also transmits nerve signal. So what happens, if you can see this, the body of the nerve cell sends out what's called an axon, and there are up to 200 of these per cell around them that don't touch. What happens then is they get to the end, before they touch the other nerve cell, they don't touch, there's a gap called the synapse. And the nerve impulse travels down the synapse, and it's a wave of electrical depolarization, but it's like an electric spark, except it's not powerful enough to jump the gap by itself. What happens is it releases one of at least 80 neurochemicals that we've identified so far. It jumps across the gap and then starts the nerve impulse down the other cell. Okay, cells in your nervous system use neurotransmitters to communicate between themselves. To communicate with the rest of the body, they use neurohormones. These are often the same substances used by multiple cells outside of the nervous system. So neurohormones, while controlled by the nervous system, that's why they're called neurohormones, are also produced by other cells, for example, ductless glands, white blood cells, colon, wherever. Okay, the nervous system is controlling other organs. The organs themselves make those chemicals as well as the nervous system. So that's why we used to think it was just nerve cells, and we found out they're all over the place. So for example, somebody's on Wellbutrin or an SSRI. So serotonin transmission. Neurochemicals are like the vocabulary of your cells. So each neurotransmitter is like a word. Same word can mean different things depending on where or how it's used. And some neurotransmitters do double or even multiple duty depending on what the circumstances are. So for example, after the word is given, it is either eaten by an enzyme in the synapse to turn it off, or brought back into the cell in a process called reuptake. So it's reabsorbed in the cell. So SSRIs, serum serotonin reuptake inhibitors, are drugs that affect serotonin levels. Serotonin, among other things, regulates body temperature, sexual response, general arousal, and amount of sensory data. So here's what a reuptake inhibitor does. So Prozac is an SSRI. LSD is the opposite of Prozac. All right? So serotonin is regulating body temperature, general arousal, sexual response, and the amount of sensory data. You have 100 billion neurons in your head, each with 200 connections to cells around them. They're not all firing at once. But what if they were? Not all of that impulse can be put into words, but if you could put in, because you do the math, 100 billion neurons, each with 200 different connections, all firing off at once, not all of that can be put into words, but if it could be put into words, it's like, as I said before, 5,000 words per second. A lot of message traffic. Do you need to pay attention to all of it? No. Serotonin acts as a sensor to screen that out. You take an SSRI, you're getting more serotonin to screen out more stuff so that you can focus. All right? So your ability to focus on me is dependent on you screening out the itch in your lower back or your scalp. Or, I'm hungry. When's this going to be over? Okay, all those things, right? In order to focus, you have to screen stuff out. Serotonin allows you to do that. And Prozac enhances that. So does chocolate. So does breathing. Okay, so what happens with LSD is LSD blocks serotonin, or it competes with serotonin for receptor sites. So essentially what happens in more data comes rushing in. Your brain, your mind attempts, notice the distinction, your mind attempts to slot the incoming signal into packages that it knows. So what happens then is, as some people have experienced on psychedelics, the room starts breathing, or I see trailers, okay? Which is actually how your brain is already processing visual information. So when I do like this, there's already 1,000 separate moments of my hand moving that serotonin has edited out. So I don't see them as after images anymore. That's why, trailers and lights and all that kind of stuff, that's why you see people doing that under the psychedelic experience. Oh, wow, it looks like a video game. Oh. Yeah, all right, that's why that works. That's why it works that way. Now, certain people can also have, and here's what the challenge is, and this is where they get you in marketing. No balance has ever been established. So when they say, oh, take Cymbalta to basically rebalance, it rebalances a certain chemical. Well, okay, there's never been a balance established. People who are quote unquote insane, you test their blood, they have normal levels of neurochemicals in their blood. So what is the balance? We haven't established a healthy balance, so what is the balance that you are rebalancing? That's just a working theory to market the drug, to explain it to lay people. Oh, I'm out of balance. Oh, I'm bipolar. I keep cycling between mania and depression, and the drug basically just stabilizes you within a narrower bandwidth of experience. Or what if life is actually complicated? Because it is actually complicated. And what you're experiencing is the normal range of emotions for what you've been experiencing. How does giving you a drug that stabilizes you help you? If we've never established a normal balance to begin with. Now, I'm not saying that people can't benefit from drug therapy. But I am saying, all right, if we actually haven't scientifically established a balance, why don't we teach people how to balance in addition to or in spite of the drug? Let's try that, because that's what's happening in cultures older than America. Oh, you uptight? Slow your breath down. Move slowly in these movements that are slowed down kung fu. Yes?
Is marijuana a...
You anticipated a slide coming up in 2 or 3.
Oh, okay.
So your tax dollars paid for this slide. Basically, it's talking about dopamine and endorphin receptors and reuptake. So here's a dopamine receptor. Here's dopamine kind of slotting in. And then there's an uptake pump that reuptakes dopamine into the cell. Here's an endorphin, and here's an opiate receptor. So endorphin means morphine within. Literally means morphine within. So it's your body's natural opiate. It's what opiate drugs are, which are usually pain meds, are working on. Dopamine resembles cocaine. And dopamine is also involved with other addictive processes.
So when you do cocaine, does it go straight to those receptors or what?
Yes, but remember those receptors are the entire nervous system.
Okay.
And cocaine in particular goes to certain areas within the brain. Okay? So, and I'll explain that when we get to... All right, so there's like 85 of these neurochemicals. And I'm only going to tell you about 10 of them because it's not that the other 70 aren't important, but the 10 of them are affected by most people's popular drugs of choice. And this theory has only been around since the early 70s. So one of the books on your book list, if you've seen it, Candace Pert's book, The Molecules of Emotion. She's the one that discovered this. So, endogenous. So, the DNA code which built bacteria and bacteria, that's another critter, viruses and Venice, endorphins and Egypt, sports an endogenous ligand system. So remember when I was talking about that scientific language of the people studying nicotine transmission, they're talking about ligands. Dopamine's a ligand. It binds to receptor sites. All these chemicals bind to receptor sites. Endogenous. Within genus, the quality of genes, beginning ligand, chemicals which bind to receptors. So, chemicals which your cells use to communicate with each other are how you think and feel. Okay? That's the basic bottom line. Okay? Other living things use the same chemicals for different purposes. So, the poppy's plant sap is not used by the poppy to make it feel better. Okay? The cannabis plant doesn't make THC to get you high. Peppers don't make capsaicin to spice up your life. Bees don't make honey just to give you a buzz. Okay, enough of that. So, neurochemicals, neurohormones, neuropeptides,